Hey guys, welcome back to our coding preparation. Let me admit a couple of more people and we're going to start. Please try to join our meeting 3-5 minutes before 11 a.m. because we need to admit everyone manually in order for you to become a part of our webinar. Okay, so let's start from our homework, which was a FizzBuzz problem, probably the most famous warm-up problem among programmers. And after that, first of all, I'm going to show you how to use LeetCode, because some people had problems with leetcode.com, which is an amazing website that helps to prepare yourself. And after FizzBuzz, we're going to do 2 more problems. I'll show you after that. Okay, so let me start from the FizzBuzz. Very, very famous problem. Do you see my screen, guys? Please select plus if you do. You should see IntelliJ IDEA right now. Great, thank you. Cool, enough. So let me create a new class. I'll call it FizzBuzz. Hopefully you were able to create the solution for FizzBuzz, and also it is important to pass your solution through LeetCode system. It automatically helps to evaluate your solution, and I'm going to show you an example with our FizzBuzz today. So I'm creating class FizzBuzz. I'm adding it to the GitHub, and the problem statement is, sorry, it looks like this. Great. So write a program that outputs the string representation of numbers from 1 to n, but for multiples of 3, it should output fizz instead of the number, and for the multiples of 5, output buzz. For numbers which are multiples of both 3 and 5, output FizzBuzz. Because it is homework, I'm not going to stop on details for homework problem, and we'll try to make it fast. So we have a time for 2 new problems, right? Okay, so remember our 8 rules. Let's copy them. And actually you have pinned, I'll share those rules again in Slack so we can refer to them, right? So share, and I'm sharing in coding interview. By the way, please, everybody should be in a Slack. It's really important. Some homeworks will be shared through Slack. Important communication will be in Slack. So please join us coding interview. You probably got the email with invitation. If you did not get any email for Slack invitation, ping me or Igor after class. We'll invite you separately. Okay, so that's our rules I shared in Slack. And first one is input. What is the input parameter? We know that basically here, input parameter is n, right? So write a program that outputs the string representation of numbers from 1 to n. Obviously, the input is n. So it will be FizzBuzz that takes int n, right? And what is the output? The second rule, output. What is the output? We have to return the array or some list of strings. So we are coding in Java, so we are going to use what is called list of strings. And if you if you read if you read the problem on leetcode.com, they provide you the template of the function you need to return. So basically, this is how it looks like if you are on leetcode.com. Let me show you. So that's a problem right here, FizzBuzz. This is actually a problem statement. You have an example of an example of correct return they are expecting from you. And this is a template. What is the template of the function they are waiting from you? As you can see, this is FizzBuzz with input n and the output, which is a list of string. Yes. So we are going to do the same thing. We are going to use list of string to return. Import list. Great. Now, how to cool. So how to do this problem? Obviously, we need to output to add to this list every single number, right? And we need to substitute some numbers with some words. But in order to do that, we will definitely need to go to iterate through every single number. That's where you can 100% be 100% sure that that for loop will come to play, because you understand that in order to play around with every single number, you need to iterate through every single number. So you need an iterator here. We're going to use our for loop, and we are going to start our I from 1 to n. Straightforward, right? 1, I less or equal than n, I plus plus. Now, we need somehow to return list of strings. So we need to create an empty list of strings first, and then slowly add more stuff to this list. So our result list is new array list. And our result list, we can add to our result list anything we want here. So now let's get back to our condition. So for multiple of 3, it should output fizz. So let's do this. How to check if the number is multiple of another number. In order to check this simple condition, we can use modular division. So what is modular division? Every programming language has this percentage. This is modular division. This is basically a reminder of division. So if you have, let's say, 7 divided by 2, this is not a whole division, right? So there is a reminder, because we can divide 6 on 2. This is 3, but 7 is not divisible. So 7 modular division by 2 will be 1, because basically you can divide 6, but 1 more is left here. This is called reminder from math. And this is a very important concept in programming. We use it quite a bit. So this reminder basically shows you if this number divides or not on this number. That's what are we going to use in our problem. So if our I modular divided by 3, and if this reminder is 0, means it is a multiple of 3. If it's not 0, it will definitely mean there is some reminder, so it's not multiple of 3. If this is true, we can add something to result list, and this is our fizz, right? Else, if this is modular division by 5, we can add, result list, add bus to our result list. Else, if our number multiples of both 3 and 5 output FizzBuzz. What does it mean? Multiple of both 3 and 5 means it is multiple of 15, because 15 is 3 times 5. So obviously, if modular division by 15 has no reminder, we need to add FizzBuzz. And otherwise, we just add the number itself. However, we are required to return list of strings, so we cannot add number there. We can add string representation of number. And we can convert this by string.valueOf and give a number instead. I made one big error here on purpose, so we can discuss it. And in the end, we can just return result list. Great. Now, let's quickly create some tests. So FizzBuzz tests. We add it here, and I'll just copy this name. Great. As I mentioned, there is one big problem with our algorithm right now. Let's test it out. So LeetCode has very simple. So first of all, you need to create some expected values, right? So if it is, I will copy from our LeetCode problem. There is expected result. Can I do this? No. Do I need to create this? By new. Yeah, it will be really hard to write unit tests here. Yeah. Right, guys, in Slack, you're absolutely right. I did it on purpose, so we can see this mistake. This is a very common mistake here. So basically, let's create m, which is 5. And we know that expected result adds, I'll need just to add it manually. Oh, not that easy. Okay. Let's do it quickly. 1, 2, 3, 4, 5. So 1, 2, fizz, 4, and buzz. This should be correct. So this is expected result, and actual result. Actual result is so you need to create class first, right? FizzBuzz equals new FizzBuzz, and now you can say let's use our function we just created from our m. And now let's assert that how do usually we write assertion? Assert array. Yes, that's what I want to do. Why? Oh, this one. So I want to assert equals that expected result equals actual result. Nice. This should be right. Just let's name it not sort array, but FizzBuzz 5. Correct. Now let's do a quick test with a little bit bigger m, which is 15, for example. So we'll need 10 more things here, right? So it is now fizz 7, 8, fizz, buzz 11, fizz 13, 14, and FizzBuzz finally. And this test, unfortunately, will fail. Why? Because our our actual result, here's it. Everything is correct, but the last one is not FizzBuzz, it's just a fizz. Why it is fizz instead of FizzBuzz? So let's go back to our solution, and we can see that whenever our I is 15, the first condition we check is it a multiple of 3? And this is absolutely true, because every single number which is multiple of 15 is automatically multiple of 3. That's pure math. So you cannot check the multiplication of 15 after you check the multiplications of 3 and 5. You have to change the order that you do check things. Like this. You check 15 first, and then you check 3 and 5. This is better. Let's quickly run our tests. So let's do both tests. And again, I'm not really stopping on details here since it was your homework. We'll talk more detailed things about our future problems. Test passes. So the next thing I want to show you is how to use lead code. That's our lead code problem, FizzBuzz. You need to register yourself. It's absolutely free. And you choose whatever language you want. We're doing it in Java. I go to my problem and I just copy my solution here and paste my solution here. And you have two buttons here, run code and submit. So run code is basically dry run. You just check that you have correct syntax and your code is buildable. It will have only one test there with very primitive input. Once you see accepted, so your primitive input works, you have correct output with expected, then you can submit. Basically, submit will run your solution through thousands of tests. And your problem will be accepted only if 100% of tests will go through. That's my status accepted here. You can see runtime. It's faster than 99% of Java online submissions for FizzBuzz. You can see your memory usage and everything else. Also, you can even see the graph. Where are you for this programming language? Great. So that's how you use lead code. Please do it for your homeworks. That's the only way you can check if your solution is correct. Now let's do not forget about other two important. So we wrote unit tests. 7 and 8 are still left. Runtime complexity and memory complexity. What is a runtime complexity of our algorithm? And what is our memory complexity for this algorithm? Please try your best and select the answer. Again, if you are not in Slack and you did not get an invitation for Slack channel, please write an email to myself, for example. Everyone has an email of mine with the link, right? So Boris Gurtovoy, Y in the end, gmail.com. Please email me and I will add you to Slack. Great. Time is big O from M. Absolutely correct. We have one for loop. And obviously, if we had 1 billion, N will be 1 billion, we will have around roughly 1 billion of operations here. What is the memory complexity? Memory, any other guesses? Right, unfortunately, we had to use big O from M, which is much worse than big O from 1. But unfortunately, we used this result list here. We have to create this. Yes, we declare a list, and the number of elements in the list is N, right? We'll place there exactly n elements, which gives us big O from n overall memory complexity. So that's our result. Good for now. I don't think you can solve this kind of problem faster. Great, that's it for homework. Let's move forward to our today's topic. We'll have one more very warm-up problem, and then we'll move a little bit further and do a little bit more interesting problem. So the first problem is warm-up, as I mentioned. Let me find it. Here it is. So maximum difference. The problem statement is easy to understand. Given an array of integers, return the difference between the largest and smallest integers in the array. Basically, you need to find the largest element in the array and the minimum element in the array, and then just take their difference. How would we go to this solution? So first of all, let's open our 8 rules, right? So inputs, obviously input is an array, right? So maximum difference, an array of integers. That's what it says, right? And the output is, what is the output here? Yes, it's just an integer, because the difference between the largest and the smallest integers will be an integer, right? So int is good here. Now, there are millions of different ways you can find maximum element and minimum element, right? It's not really that hard. Let me try to show you what will be the best approach if you got this problem on the interview. So that's the only condition you have here, right? So basically, you don't have any specifications for now. Sometimes you'll be given with the problem, and then some extra conditions will come along your way. For example, let's say, first of all, try to write an example for yourself, as a lead code shows you, right? It's a good approach and it helps a lot. So basically, let's assume we have an array. We have 2, 1, 9, -5, 10, and 4. So what will be the correct answer here? -15, correct. So 10 minus -5 gives us 10 plus 5, which is 15. That's the difference between the largest and the smallest elements. Now, the first approach you can think of can be, what if we are going to sort our array? So sorted array will give us something like -5, 1, 4, sorry, 1, 2, 4, 9, 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Great. So if you sort your array, you'll have something like that, and you can easily get the minimum element, which is always first element, and get the last element, which is also always the biggest element. So let's assume I start my solution from the sorting. So obviously we're not going to implement our own sorting today. We'll have the dedicated session for that, because sorting in general is one of the most interesting problems in algorithms, sorting of arrays. So basically, let's say you can use native arrays.sort. let's assume, and you provide the array. It sorts the array. And then you can get min element, obviously will be the array from 0, right? And max element will be array of last index, which is array.length -1, right? The whole length of array -1 will be the last index, and we're going to use the array of last index to get the max element. Obviously, if you go with this approach, do not forget to check that your array has element 0 and element length -1. So basically, you need to have at least one element, right? Otherwise, it will be a crash. You are going to try to get the 0 index, and you will get index out of bound exception right here, which is very bad. So you check that if array.length less than 1, let's just return -1, for example. It means that there is no minimum element and no maximum element, so just return -1. Okay, so let's assume you started from sorting on your interview. You have to know some things about sorting. Sorting is very expensive operation. As for today, people did not invent how to sort arrays for big O from n. There is no such sorting algorithm that will do that with adequate memory complexity. There is one algorithm that will give you runtime complexity big O from n, but it will eat extremely a lot of memory, which is not good for us as well. So unfortunately, today, people do not know the fast sorting algorithm. Even the native Java sort, which we use here, arrays.sort, will take n times log n. This is for today the best average runtime complexity that people invented. For today, you don't need to know how you can prove it. Again, we will have the dedicated session for sorting, but you need to know for sure that the best sorting you can achieve, this guy uses usually quick sort. This is a special algorithm for sorting. And the complexity is n times log n. Do not worry if you forgot what is the log. Please Google after this lecture, because we're not going to use today, but we will use heavily this little guy later in future sessions. Again, so this is, obviously this is more than big O from n. This is more, this is worse complexity, right? So it's very expensive to use sorting here. Basically, if you have 1 billion elements, it will take much more than billion operations to achieve this min and max. So this is not good approach. And when you are solving this algorithm, you can talk to your interviewer. You can say, so this solution is not optimal because I use sorting here, and the sorting, as we know, takes n log n operations, which is quite expensive for this problem. So let me optimize my solution a bit. Basically, it will be first draft. And now let me create the correct one. Sorry, and now obviously you need to return max element minus min element. This is correct solution. It will work, but it will work too long. It will take too many operations to achieve the simple maximum difference if the array is huge. And that's how we measure things. Hopefully you saw my first lecture 1 week ago. Now, what can we do without sorting? We can slowly move. We'll still leave the condition we should have more than one element, otherwise this problem does not make any sense. And now we can slowly iterate. We can slowly iteate through our array, and every single element, every single iteration will compare the minimum element and the maximum element with our current minimum and maximum. With this approach, we will continuously update our min and max elements. And it will take only one for loop, which is big O from n. So let me create the for loop from 0 to array.length. And let's create, oops, what's going on? How did I, here, great. Let's create min something, what default value, right? And max default value. We need to somehow take the default value. What do you think we can take in order to do this problem? What are the good default values here? Absolutely. So we have two options right here. First intuitive decision here can be 0. But that's not a good approach. Why? Because your array can have, let's say, all elements will be less than 0. Then you will not be able to update your maximum, because your maximum will be 0 and it will be always bigger than every single number if your numbers are negative, right? So you can do either the max value for minimum and the min value for maximum. In that way, you will always update min and always update max, because definitely you will see some integers that less than your current minimum and that bigger than your current maximum, because your current minimum is the biggest integer ever, and your maximum is the minimum, the smallest integer ever. So obviously you update them. But even better, I like the approach, just take the first element. In that case, you will definitely update them later. And you can do this without any, without worrying you'll get a out of bound exception, because you have a check here. You definitely have the first element. And this way, the rest of problem is quite straightforward, right? If our element bigger than your current minimum, then your minimum is not your minimum anymore. Your minimum is, you found, if your, if your current element is bigger than your current maximum, then your maximum is not the biggest anymore. So you update your maximum with your current integer. Clear, right? If your current integer is less than your current minimum, that means that your current minimum is not the smallest anymore. You found something that is smaller than your minimum. So time to update your minimum. Your new minimum is this element. With this approach, by the end of for loop, your minimum will be the smallest in the array and your maximum will be the biggest in the array. So you can just subtract min from max. Let's write some unit test. Questions, meanwhile. No questions? Can you provide pluses if you understand everything, minus if you have some problems, or plus minuses if you more or less understand what's going on? Nice. We have a question. Why did we use array gore, min, and max instead of string? I didn't really understand what do you mean by, oh, nice. Why did we use array of min and max instead of string? Why did we use array of min and max? We don't have any strings here. Are you sure you understood the problem? So we don't have any strings here. We have an array of integers. That's it. Basically, there is no more strings. We just have an array of integers, and we are required to find the maximum difference between two numbers. Void what do we have here? Void max difference test. So maximum difference is new maximum difference. Actual. Let's create an array, right? So array is, let's use our test array that we used right here. I like this array. I'll just take it, and we know that the expected result is 15, right? So we are going to use that, and we know that expected result is 15 here. So actual result though is maximum difference dot maximum difference for array. And we just wanted to assert that our expected result equals actual result. That's it. Let's run some tests here. And test passed. Great. I don't remember, do we have the lead code problem for this? So I'm not going to pass my solution for lead code. So again, it's absolutely normal if you started with not optimal solution and then you corrected yourself. You said, well, it's not optimal, so let me show you how to a little bit optimize it. That's absolutely normal. And moreover, interviewers usually like this approach. Sometimes you are going to use something, let's say native sort, and they don't want you to sort. But the overall complexity is still n log n, let's say, the best runtime complexity for this algo. But you're used the arrays.sort. If you were not specified, do not use native sorting in the condition, that's absolutely normal as well. Usually interviewer will give you an additional condition in the middle of the interview. They'll ask you, now let's do this problem a little bit more complicated. Let's not use the native sorting for our solution. And that's absolutely normal as well. You just basically do the next iteration without sorting, right? Great. Also very popular to do brute force. We're going to learn what is brute force next Sunday. Brute force first, and brute force is basically just iterating through everything you can iterate. And sometimes you'll find the correct solution, but it would be definitely not optimal. So it's okay to do a brute force solution first, and then you can say, well, I understand that this is not optimal. Let's try to do a better complexity, and I will show you how. Great. That's it for this problem. The last problem for today is my favorite one. I personally use it very often on the interviews. One second. What is the complexity of difference? Great question. We did not do it. We didn't cover. Sir, thank you so much. Very important to go through all 8 questions, our 8 rules. Thank you. Sometimes I forget, but please do not hesitate to correct me. So we wrote unit test 7, runtime complexity. For now, we covered this runtime complexity, right? We understand that this is runtime complexity is bad, analog n. For our new runtime complexity is, yes. So this is again big O from M. Do not forget that this is the only runtime. Do not think that this is the only runtime complexity we have. Believe me, very soon we'll see n square and n log n and just log n, lots of different examples. So this is n log n, and this is big O from n. What is memory complexity here? Correct. Yes, we did not use any additional data. We just used 2 variables, which is nothing for our computers, so that's not a problem. Time is perfect. Sorry, memory, right? Memory is perfect. Big O from 1. Great. Our next problem is called Palindrome Problem. Palindrome Problem. My favorite one. What is a palindrome? A palindrome is a word, phrase, or sequence that reads the same backwards as forwards. For example, A, B, C, B, A, or A, B, D, D, B, A, or Anna, right? You can Google even some phrases, the whole phrase that you can read backwards, same as forwards. Race car, thanks Natalia. Let's write it here, race car, great one, I'll use it. Yeah, you can Google even big phrases. This is a very common thing, and there are lots of algorithms that use this concept. Abu was I, area I saw Elba. Great, wow. Yeah, so you can play around in your unit test with that. Great, there are lots of interesting phrases that are palindromes. Our question is, write a function that takes a string and returns Boolean whether this string is palindrome. Whether a string is palindrome. Great. Cool. Again, there are lots of different potential solutions here. We are going to cover some of them today and some of them in the second part of our bootcamp. Case sensitive, ignore characters. This depends on the interviewer. That's a very good question to ask from your side though. You should ask first thing, are we case sensitive and do we ignore any special characters like comma or space? For our purposes, let's assume it is case insensitive and we do not ignore characters. So basically only if string is completely reversible, we count it as a palindrome. Right? So we're not going to clear our string from characters and other stuff. Basically, this is not a palindrome. This is a palindrome only. This is a little bit easier. Great. How to do that? And again, many different approaches here. The first you can think of is so basically we return bool, right, boolean, and we can name it is palindrome. Usually if your function returns boolean, it's a good approach to name it from is or some action. So basically is palindrome, yes or not, right? The input parameter is a string here. So input is string, output is boolean. Now, what approaches can we use? Basically, the first approach we can try to use here is, what if we are going to say string reversed str equals str, no reverse here, maybe string dot reverse. I'm pretty sure there is some reverse here. I didn't use Java for a while. Doesn't really matter. If you're going to start with most trivial cases, singular to character string, then iterate to longer test values, sort of inductive style. Yeah, that's a good approach. Okay, so basically there is some native way to reverse. I'm pretty sure. Let me read it. Reverse a string in Java. Sorry, guys. Anyway, yeah, we need to create string builder for this. So you can do something like new string builder. Let's assume you know this. I didn't know that for a while. Yeah, only string builder, absolutely right. So basically you can say string builder from str, then use reverse, and then use toString. That's something you can probably start thinking of, and then you can return str equals, do not compare strings like that, string. That's something you need to always remember of. In Java only, if you want to compare two strings, you should not try to compare them by equal, because that will fail. Usually it's better to use equals function. So basically you can say return reverse string equals and then use str, something like that. So that's probably the first native approach you can try to think of, right? Let's assume you did remember the string builder approach, or you Googled it, doesn't really matter. Absolutely normal. The next thing interviewer will ask you, they will say, great, now let's make it a little bit complicated. Let's not use the native reverse approach. So we are not going to use string builder. That's an extra condition interviewer can absolutely give you in the middle of the process. So we cannot reverse ours. With the native approach, we can think, okay, let's just write a reverse function and reverse our function manually. We can do that, absolutely. we can say that or from 0 to string length, or even we can start from the last one, and go until I will reach 0 and do minus minus. So basically in the reverse way, we start the index and we create our string reverse string, which is empty by default, but then we slowly up. I thought it's append. Okay, we can just use this. Append the string char at I, like this. So basically you start from the end and you slowly append to your reverse string, right? And then the same, you just, you build your reverse string by yourself with this approach, right? And that's absolutely normal. That's a good second iteration for this algorithm. Usually, interviewer at this point will say, okay, what is your time complexity and what is your memory complexity? So what is the time and memory here? So time is definitely big O from n because we have a for loop that runs exactly length of string. By the way, what is n? What is n, guys? It's always important when you're on the interview, specify what do you mean by n, because we do not have any n's here. There is no such thing as n. So do not forget to say what is n. So your time complexity, I would answer like that on the interview. Time complexity is big O from n, where n is the length of my input string. Correct. Important to specify. And right, time is big O from n, and the memory is big O from n as well, because basically you will build the second string, which is same length as your input strings. If your input string had billion chars, you will create a second string with billion chars, which is time consuming. So memory is big O from n. Now, this is fine. I don't think you can do this program in the better complexity. Just a little bit, but the overall will be big O from n still. So each plus equals will relocate the string each time. That's true, but in the end, you will still like allocate the string, which will be the huge. The final string will have n chars, and your n can be billion or trillion, whatever, right? We can do big O from n times 2, which is still big O from n. Absolutely right. We can a little bit do more optimal, but still be overall average big O from n. And how to do that? So basically, we need, the memory is bad. So this algorithm should be solved with constant memory usage. How to do that? We are not going to create our reverse string. We are going to iterate slowly through our string. And every time, actually, sorry, let me leave this algorithm as well and create the second one. Like this. So is palindrome first draft? I'll try to leave for you those drafts so you can revisit them later. Great. So what if we are going to slowly go in case of string builder reverse, what will be the time and memory complexity? The time, that's a good question. We should look up the time of string builder reverse. I assume this is linear time. I assume it works for big O from n. You can go for documentation and take a look on that. I assume it's big O from n as well. And memory is obviously also big O from n, because whenever you reverse your string, you save it. Yes. Aaron, absolutely correct. So the next iteration, we're going to do this, what is called in place. In place means without allocating any additional memory. We have a string, so let's use our iterators to work with the same string and try to identify whether or not this is a palindrome. What can we do here is for int I equals 0, I less than str.length I plus plus. We are going to slowly move to the right, and every time we're going to identify the left char and the right char and try to compare them. If they are not equal, this is definitely not a palindrome. If they are equal, that's not enough to say this is a palindrome. We should move forward and compare the second letter with the second to last. If they are not equal, this is enough to say this is not a palindrome. If they are equal, this is not enough to say they are a palindrome. We should move forward, and so on and so forth. So basically, left char equals str.char at our I, right? Our index I, from 0 to the end. Right char equals char at, this will be the last one, but we do not want to hard code this to the last one. We want to check the last one first, the second to last second, the third to last third, and so on and so forth. So basically, what if we are going to subtract I here? Because our I is 0, 1, 2, 3. In case of 0, we're going to have the last one. In case of 1, we're going to have the last one minus 1. In case of 2, we're going to have the last one minus 2, and so on and so forth. So we're going to check last one, the second to last, the third to last, and so on and so forth. So if array from left, if left char does not equal to right char, it is enough to say that this is not a palindrome. So we just immediately return false. Otherwise, we should go through the whole for loop, and only in the end, if we still did not return false at some point, we can definitely say this is true. And there can be some optimization, right? We can definitely say we don't need to go after the half, right? It's enough to go to the half, because with right char, we'll cover the second half immediately. So absolutely right, we can go to the divided by 2, the length divided by 2. Let's do some unit tests according to our rules. What's our annotation there? This one. So let's create the palindrome. Then int expected result equals palindrome. Let's create the string itself. So string itself will be, I like the race think, I'll use that. Race car, right? Race car. String str equals race car. So we know that int expected result, sorry, is true. This is a palindrome, right? And sorry, absolutely Boolean. And we know that actual result is palindrome str. So as usually, we will try to do another one, assert. So assert, whenever you're using assert, make sure you use JUnit assert. This one, second. Assert equals expected result, actual result. Let's try it out. Passed. Also, let's try to do negative one. No palindrome. False palindrome. So let's just do A, B, C, D, B, C, A. That. So expected result is false, right? Now let's talk about edge cases. Absolutely right. The next correct logical test case will be, let's try to do empty palindrome. Empty palindrome. Empty palindrome is definitely a palindrome, right? Because you can reverse this and it's still true. In our case, we're going to, empty one, right? In our case, we are going to pass it. What if we're going to use one letter palindrome, like S? It should be a palindrome as well. And it's true as well. We also should test strings with even numbers of chars. Absolutely. So let's try to do even thing. Here we have 1, 2, 3, 4, 5, 6, 7. Let's try to do A, B, C, A, B, B, A, like this. This is true, right? So very good. Let's just name it test even palindrome. Great, passed. So it passes. Great. Questions? Your homework. Integer palindrome. Integer palindrome. What does it mean? Write a function that takes an integer and returns Boolean, whether this integer is palindrome. Do not use integer to string conversion. Transformation. Very good. What's the time and memory complexity? Please do not hesitate to remind me those things. So obviously we have for loop and we are, so try to guess what is time and memory complexity here, including this divided by 2 length. And we shouldn't test case sensitivity because in the beginning of this problem, we specified that we ignore case sensitivity and special characters. But that's a very good question to ask in the beginning. So time here, we can try to say that basically this is big O from n times 2, right? But with math rules, math analysis rules, we covered this last time, we know that basically this coefficient is not really important, because if your n is incredibly large, we don't really care 1 trillion or half of trillion. It doesn't really matter here. So basically we drop any coefficients. So it's still linear time, big O from n, even though the correct time is divided by 2. And memory is big O from 1 here because we didn't use anything. We just did it what is called in place. Homework. Integer palindrome. So you write a function that takes an integer and returns Boolean, whether this integer is palindrome. So the same thing, but with integer. And the extra condition is do not use integer to string transformation, also called casting. Very good question. No negative integers. I will edit my takes a positive integer. No negatives here. So only positive integer and returns Boolean, whether this integer is palindrome. Do not use integer to string transformation because you can do just string value of integer and do the same problem here, right? Obviously, what is integer? Palindrome is, let's say, 1 to 3 to 1. So this is a palindrome because 12,321 is same 12,321 in the opposite direction. Is homework clear, guys? Thank you. The GitHub solution and the video recording will be available today. Thank you for attention. See you next week.